tutorial, I'm going to talk a little bit more about z-scores, and this was a question submitted by a goddess that needed help with her homework. All we need is the mean and the standard deviation to answer the following questions, and I'll go through the questions one at a time and address them individually. Remember, 100% of the observations fall under the bell curve. The mean from the problem is 178. There's a 50% chance that an observation will be below the mean, and there's a 50% chance it's above the mean, which is the answer to one of the questions, which is number 3. What is the probability that a man in this age group has a cholesterol level greater than 178? It's 0.50, or a 50% chance. Now, the next problem in the question is, in what percentile is a man with a cholesterol level of 190? The formula we're going to use, or I'm going to use, is z is equal to the observation minus the mean divided by the standard deviation. I'll draw in 190 where I think it is, and a percentile is all scores below 190. So it's this area here, and it's also that area there. Will tell us the percentile. There's a 50% chance observations are below 178, so we don't need to recalculate that area. So z is equal to 190 minus 178 divided by 40. 40 is the standard deviation, 190 is the observation in question, and 178 is the mean. This works out to be z is equal to 12 divided by 40, or z is equal to 0.30. This z-score is the area between 178 and 190. We already know the probability below 178, which is 50%. Now we need to determine the area between 178 and 190. 0.3 is the z-score related to 190. In the back of most statistics book, there's a normalized table, and we look up that 0.30 in that table. It should be 11.8%, and I'll run that to 12%. So we take 50% plus 12%. That equals 62%, which is 62%, and the same as 62nd percentile. Now we move on to another problem. The way we solve this one is, it's all the area to the right of 145. Everything to the right of 178, we already know, which is 50%. We're going to use the same z formula as we used before. Z is equal to 145 minus 178 divided by 40. It's the standard deviation. 145 is the observation in question, and 178 is the mean. Z is equal to negative 33 divided by 40. So z is equal to negative 0.825. This z-score relates to 145. Remember, the z-score of 178 at the mean is 0. 0.825 equates to, in the back of a stats book, would be 29.67, or about 30%. Now I take 30% plus 50% is equal to 80%. So there's an 80% chance, or we can say the probability is 0.80, and that's the answer. What cholesterol level corresponds to the 75th percentile? This area is 0.50, or 50%, and this area we don't know about. We know it needs to be 25%, but we don't know what the z-score is. If you look up 0.250 in the body of the table, of the normalized table, the z is 0.68. So z is equal to some observation, which we're trying to determine, minus 178, the mean, divided by 40. We take that 0.68 and we put it over there for the z-score. So z is equal to that now, 0.68. Now a little algebra. We're going to multiply both sides of the equation by 40. The 40s on the right-hand side of the equation cancel out. 40 times 0.68 is equal to 27.2. And this equals to the observation minus 178. Again, a little bit more algebra. We add 178 to both sides of the equation. So this equals to 205.2, and that's our observation. So this is the observation in question that we've been looking for, and that's the answer to the question as well. 205 is a cholesterol level that corresponds to the 75th percentile. This problem is slightly different than the previous that we've done because we're going to find the area between 2 points, in this case 155 and 185. We're going to find out what is the probability of a man falling in this area. The first thing was to calculate the area between 155 and 178, which is this area right here. Should fade in right now. So Z is equal to 155 minus 178 divided by 40. 40 is the standard deviation. 155 is the observation in question, the first observation. 178 is the mean. 155 minus 178 is equal to negative 23 divided by the standard deviation, which is 40, is equal to negative 0.575. Now, if you look that up in the back of your book, in the standard normalized table, that should equate to 0.2190. Next, we'll calculate the area between 178 and 185, this area here, right here. So this time we have Z is equal to 185 minus 178 divided by 40. That's our standard deviation again. 185 is our observation and 178 is the mean. 185 minus 178 is 7, the last time I checked, divided by 40, which is equal to 0.175. So now we're going to take 0.175 and look that up in the back of a book in your normalized table, and that should equal 0.0695, small area. And I'm going to add that to 0.2190, and that equals 0.2885. And that's the probability. And that's the probability of a man's cholesterol being between 155 and 185. Notice this time we have a sample size of 100 men. So now we have 175, and we know the area, we want to find out the area to the right of that, which is the probability also. So we have to find the area between 175 and 178. Since we have a sample, our formula is slightly different. Notice now we take standard deviation divided by the square root of the sample size. This is also known as the standard error of the mean. Now we just have to plug and chug. So we take the observation of 175 minus the mean of 178 divided by the standard deviation, which is still 40, divided by the square root of 100. So Z equals to negative 3 divided by 40 divided by 10, which is the same as negative 3 divided by 4, which is equal to 0.75. So that's that Z value, and it equates to 27% in the back of your book. So adding those two together, we find out that the probability is 0.77. And that's it, the answer to your question. And that should do it. And this time, shop more, study less.